All right, we're looking at review for quiz 2. I wanted to run through the answers real quick, kind of talk you through it, make sure we're all on the same page before we take the quiz tomorrow. On the first one, is there a C in the closed interval between 0 and 2 such that there is a 0 for the function f of x equals x to the fifth minus 2x cubed minus 2? If so, prove why. So it wants to know, does f of c equal 0? So first thing I need to do, if I'm going to use the IVT, is show that it's continuous. My function is not a fraction. It's not a piecewise function. It's not a trig function. So that means there are no continuity issues. So I can go ahead and say f is continuous on the interval. Make sure you always tell me it's continuous on the interval they give you. Okay, don't just say it's continuous. Make sure you say it's continuous on the interval. Then we find our function values. So f of 0 equals -2. F of 2 is 14. 0, 0 is in between -2 and 14. So I need to show that. So f of 0 is less than 0, which is less than f of 2. And then I'm going to say the same statement every time. Usually, the only thing that's going to change is my interval right here and whatever f of c equals. So therefore, by the IVT, there exists a C on the interval. Notice that this interval is open, whereas the original interval was closed. So on the open interval, such that f of c equals 0. All right, number 2, is there a C on the closed interval such that f of c equals -1 for this function? If so, prove why. So this one is sine. Remember, sine and cosine are always continuous. So that means there are no continuity issues on this. So I can go ahead and say f is continuous on this interval. I want to figure out what f of 0 is. So I plug 0 in. Sine of 0 is 0. And 0 minus 0 gives me 0. I plug in pi over 2. Sine of pi over 2 is 1. And plug in pi over 2 there. I get 1 minus pi over 2. 1 minus pi over 2 is a negative number. That's between 0 and -1, and -1 does not fit there. So I say no, there's not one, because -1 is not between 0 and 1 minus pi over 2. Number 3, is there a C on the closed interval 0 to 3 such that f of c equals 10 for my function? Again, this thing is continuous, no fractions, no piecewise, no trig, so it's definitely continuous. I need to find my function values of the endpoint. So f of 0 equals 0. F of 3 equals 12. 10 is between 0 and 12, so I need to show that. F of 0 is less than 10, which is less than f of 3. And then I'm writing my statement again. Again, the only two things that changes are those two. So therefore, by the IVT, there exists a C on 0 to 3 such that f of c equals 10. Number 4, we did number 4 in class. But we'll go ahead and hit it again. So this time it wants to verify that the intermediate value theorem applies. And then this time what's different about it is we're actually going to find the C that the IVT guarantees. So again, start by continuity. That thing's continuous. I find my endpoints, -5 and 125 are my values. 13 fits in between those two, so I show it. So there I have verified that the IVT applies. Now I need to find my value of C. Again, 13 is a y value, so that means I plug 13 in for f of x and I solve for x. So I plug 13 in, I add the 3 over, gives me 16. I divide by 2, which gives me 8, and I take the cube root, which gives me x equals 2. We're wanting to find a c, so we go ahead and change it to c equals 2. And all right, so we move on to 47. So here, all of our limits are approaching either infinity or negative infinity. So that means we're interested in horizontal asymptotes. Remember, if I'm doing infinity or negative infinity, um, my answer should be a number, positive infinity or negative infinity, but we're going to see over here on 56 that we don't get either one of those. All right, so 47, again, I got a fraction. I always want to put my fractions together, so I get a common denominator. I get 8x plus 1 over x. My variables have the same exponent, so I take the coefficients. We get a limit of 8. So that means I have a horizontal asymptote at the y value of 8. The next one, exponents are the same. Take the coefficients, gives me 2/3. Next one, top exponent is larger than the bottom, so that means we either got to go to infinity or negative infinity. So we're going to negative infinity. So if I plug in a negative to the top, it's going to be positive. I plug a negative into the bottom, it's going to be negative. A positive over negative tells me I'm going to negative infinity. So what that means is as my x values are headed out to the left, I'm eventually going to go towards negative infinity. The next one, I'm dealing with cosine. Remember, cosine can only equal values between -1 and 1. I multiply that by 5. So that means my top is only going to equal values between between -5 and 5. I plug in infinity on the bottom. That means I'm dealing with a number over infinity, and we learned that a number over infinity is equal to 0. Next one, we're going to negative infinity. So again, variable and variable matches. So I take 6 over 1, which gives me 6. Now, some of you may be getting hung up on cosine, but remember, if I'm dealing with cosine, that means this value right here is only going to toggle between -1 and 1. It's going to equal values between -1 and 1. So this is no different than like x plus 0.5. So just like there's an x plus 5 right here, I didn't care about that 5. Well, this cosine is no different than that 5 because it's only going to be numbers between -1 and 1, and it doesn't affect the problem. Next one, exponent on the top, exponent on the bottom, they're the same. So I take those coefficients, I get -1/2. 50, exponent on the bottom is larger, so that means we get 0. 52, if I take the square root of x squared, I'm going to get x, so that means my exponents are the same. The coefficient up top is 1, coefficient on the bottom is -2. Now this one is slightly different. Notice I got a positive 1/2 instead of a negative 1/2. That is because anything I put into the top, when I take the square root of it, is going to be positive. And when I plug in to the bottom, since it's a negative infinity, that would turn that into a positive 2. So that's how we ended up with a positive 1/2. You got to be careful with the square roots because those are the ones where the signs can be different. So the next one, I have 3x over the square root of x squared plus 4. Square root of x squared gives me x. This time I'm going towards infinity, so the signs I'm not gonna worry about the signs. My signs that I see are what I'm gonna get. So I get a 3 over a 1, so that ends up giving me 3. Now the last one, going to negative infinity. So here, if I put a negative infinity in, that gives me a negative infinity on the top. If I put negative infinity on the bottom, remember that sine equals values between -1 and 1. So that means my bottom is going to toggle between positive and negative values as I continue to go to negative infinity. So my top is going to be negative infinity. My bottom is going to toggle between a negative and a positive. So that means I cannot say that it's going to infinity or negative infinity. It's going to be bouncing up and down. So that's why we chose D and E for my limit there. All right, down here, we're going to X values, actual numbers. Remember, the first thing you have to do when you're plugging in actual numbers, or when you're going to a limit, when you're approaching an actual number, let me spit it out. So when you're approaching an actual number, make sure you plug it in to begin with. So if I plug in -2, plug in -2 on the top, I'm going to get a number. Plug in -2 on the bottom, I get 0. A number over 0 means that I have an asymptote. So now I need to figure out whether or not we're going to infinity or negative infinity. So again, I want to think about plugging in a number just to the left of -2. If I plug in something just to the left of -2 on the bottom, it's going to be negative. Plug in something just to the left of -2 on the top. If I plug it in there, I'm going to get a positive value that's bigger than that value. So the top's going to be positive. So I get a positive